Okay, I'm going to show you how to using online softwares to find linear regressions. We have two ways. One is using Desome, which is a website. Another one is using Excel. So if you want to do Desome, you're going to searching decimals, and then we're talking about the graphing calculator. And your decimal is going to looks like I think that's the largest I can go. So your decimal is going to look like a page, have some area for you to enter your equations or sets of data, and then the other one is more like a graphing papers. So I'm going to do a list of informations. So I'm going to choosing or click on the add items, and I want to adding informations in terms of table. So I have x sub 1 as our independent variable and then y sub 1 as our dependent variable. I'm going to type in some informations. I'm going to type in few numbers. I think that's good. I probably just fill in the rest. 120, 110, 100, and 110. Okay, I'm going to enter in 11, 22, 21, 15, 9, 15, and 10. Okay, so those are my data. So if you're moving the graphing the grid, the graphing areas, you're able to see the dots are located here. Okay, then what do we want to know is we want to have approximate relations between our those points, in particular between our x1 and y1, those two variables. So I'm going to do y1, y sub 1, and I want it to be approximated using the mx plus b, but we do not have x, so I'm going to do x sub 1. So once I have this one, which is asked decimals to do approximation for a best fit line between those data, so we have these lines, and then we have our statistic informations, which is the r squared and then the r. So those are our correlation coefficients, and then this gray dot is our y-intercept, has x value 0, y 38.75. For this information, because our x range is ranging from 100 to 120, x equal to 0 do not have any meanings according to this set of data. Because the information we have here, we use here is x1 is the calories and y1 is the carbs. So it doesn't mean when you have a 0-calorie food, the carb is going to contain 38.75. So for these situations, the y-intercept does not make any sense. So this process is only give us a good fit line, which is the slope is negative 0.225, the b is 38.75, can help us to predicting anything fall between x equal to 100 to x equal to 120. So for example, if I want to predicting any cereals has a calorie of 105, it's probably going to have where is here? Probably going to have a carb of 15.125 gram. Or I want to predicting like a cereal has a calorie of 110 is going to have approximately 13.98 for the carbs. But you can see this is the prediction. All the information I have for the calorie of 110 do not fall onto the 110, 14 gram. So this is only the predictions, but this is a really pretty close predictions. Because for those we have 13, we have 12, we have 11, we have 10, we have a 9, and then we have a 22, which 22 is definitely really, really high. This is just a best distance or best point, best predictions, which is, I think it's about 14, which is the best predictions for all the informations we provide to them. Okay, so that is how you're going to finding the equations basing on, or the best fit line equations basing on the informations you have using decimals. Okay. So if I want to use Excel, I'm going to have, okay, so if I want to use Excel, I can do pretty much similar things. I'm going to still have my datas. Okay, so 120, 110, so once I enter in the datas, if you want to, you can have like a title to say this is the calories and this is the carbs, and then you want to have a graph like this one, and then you want to have a best fit line. So what you can do is highlighting the data sentence or the data tabs, and then you're going to do insert a graph. We want to do a scatter plot, which is pretty much just all the dots anywhere. We do not need any of those fancy ones. We just do the regular, just pure dot scatter plot. Okay, so once we have them, you can do the long route, or for me, I'm just going to do the quick layout. And there's one symbol-wise have f of x. That it says this one, this quick layout will give you the equations and then the residuals. I cannot make it larger, but hopefully you can see it. Okay, so that's the equation, y equal to negative 0.225x plus 38.75 with the residual correlation coefficient square is 0.1164. If we want to comparing this with decimal, we got the same number, negative 0.225 for the m, and then we got same b, 38.75 for the b. We got the same r square, 0.1164, and the decimal also give you the r, but you can calculate the r by taking the square root of the r square. And then you know this is going downward, so it's going to be a negative correlation coefficient. Okay, so your project for this time is going to base on those cereals brand with all the informations you have, and you're going to choosing two variables to predicting the relations between those two variables. For example, the ones I picked, which is the calories and carbs, is that means more calories, more carbs, or less calories, less carb, or more calories, less carb. Based on the graph I have, because of the trend here, I can conclude is less or actually more calories. I think this is a cereal. Tend to have less carbs. When I have more, I probably make changing the titles to matching with the data. Okay, so you can see when I have more calories, I will have less carbs. Again, this is just for in general speaking. It doesn't mean for every two. If you're comparing those twos, this data and this data here, you can see I increasing the calorie levels, but also increasing the carb levels. And this one, I increasing the calorie levels, but remain the same for the carb. But if you're comparing those two, you can really see the dramatic decreasing. So the conclusion we can draw is based on all the data and just draw a general conclusion. It doesn't mean it doesn't apply to every single individuals, but we can using this one to predicting any future ones.